From the smallest atom to the largest star, the universe is governed by a set of fundamental principles. These principles dictate how energy behaves, how systems interact, and how the cosmos itself unfolds. We call these principles the laws of thermodynamics, and they offer a fascinating glimpse into the machinery of existence. Thermodynamics, at its core, is the study of heat and its relation to other forms of energy. It explores how energy transforms, flows, and influences the world around us. While the name might sound intimidating, the basic concepts are surprisingly intuitive. Imagine a cup of hot coffee left on a table. Over time, what happens? The coffee cools down, eventually reaching room temperature. This simple observation hints at the fundamental principles governing energy exchange. The laws of thermodynamics provide a framework for understanding these everyday phenomena, but their reach extends far beyond our kitchens. They underpin the operation of engines, the behavior of stars, and even the evolution of the universe itself. The first law of thermodynamics is perhaps the most intuitive. It states that energy cannot be created or destroyed, only transformed from one form to another. This principle is often summarized as the conservation of energy. Think of a bicycle pump. As you push down on the handle, you're expending energy. This energy doesn't simply vanish, it's converted into mechanical energy, which compresses the air inside the pump. This compressed air, in turn, stores potential energy. Similarly, when you burn a log in a fireplace, the chemical energy stored in the wood is released as heat and light. The total amount of energy remains constant, even though it changes form. The first law has profound implications. It tells us that there's no such thing as a free lunch in the universe. Every action, every transformation, involves an exchange of energy. We can't magically create energy from nothing. We can only manipulate what already exists. The second law introduces us to the concept of entropy. Entropy measures disorder within a system. It states that entropy in a closed system increases over time. Imagine a pristine sandcastle on a beach. Wind and waves will cause it to crumble. This is increasing entropy. Usable energy decreases as entropy increases. Waste energy contributes to entropy. The second law impacts the flow of time. It explains why certain processes are irreversible. Entropy acts as an arrow of time. Section 4. The third law, reaching for absolute zero. The third law of thermodynamics deals with absolute zero minus 273.15 degrees Celsius or 0 Kelvin. As a system approaches absolute zero, its entropy approaches a minimum value. At absolute zero, all molecular motion ceases. However, reaching absolute zero is impossible. The pursuit of ultra-low temperatures has led to remarkable scientific discoveries. Section 5. The zeroth law, a matter of thermal equilibrium. The zeroth law of thermodynamics might seem obvious, but it's crucial for establishing the concept of temperature. It states that if two systems are each in thermal equilibrium with a third system, then they are in thermal equilibrium with each other. Imagine 2 cups of coffee, one hot and one cold, placed on a table. If you leave them alone for a while, they'll both eventually reach room temperature, the temperature of the surrounding air. At this point, they are in thermal equilibrium with the air, and therefore, with each other. This law allows us to use a thermometer to measure temperature. When a thermometer comes into contact with an object, they exchange heat until they reach thermal equilibrium. The thermometer then displays a temperature reading that reflects the thermal state of the object. Section 6. Thermodynamics in our lives from teacups to stars. The laws of thermodynamics govern everything from car engines to the sun's nuclear fusion. They explain why perpetual motion machines are impossible and why stars burn out. These laws guide our understanding of energy efficiency and climate change. Understanding thermodynamics reveals the order in the universe's complexity.